Thus, the standard form of the quadratic equation, as I told earlier, looks like this: ax square plus bx plus c is equal to 0. Here, a, b and c are known values. A should not be equal to 0. If a becomes 0, what will happen? The x square coefficient is 0. The term x square will not be there, so that it will be a linear equation bx plus c. Quad means it has got a double solution, that is quadratic equation. So x is a variable here in this equation, ax square plus bx plus c is equal to 0. For some example, let us see 2x square plus 5x plus 3 is equal to 0. In this, a is equal to 2, the coefficient of x square, b is equal to 5, the coefficient of x, and the constant term c is equal to 3. And another equation I consider as example, x square minus 3x is equal to 0. Here you can factorize as x into x minus 3. So it is a very tricky. X is equal to 0 and x is equal to 3, two solutions you are getting. Now let us see in this session the quadratic formula, properties, and some trick using this quadratic formula to get the solution for the quadratic equations. Consider x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Here you get two values for x, namely x1 will be equal to minus b plus square root of b square minus 4ac whole divided by 2a, and another root will be x2 will be minus b minus square root of b square minus 4ac whole divided by 2a. So here the x means that we need to do a plus and minus so that you are getting two solutions for the quadratic equations ax square plus bx plus c is equal to 0. That is the quadratic equation ax square plus bx plus c is equal to 0. Here within the square root you get the form that is b square minus 4ac, that is deciding the root nature. So it is called b square minus 4ac is called the discriminant, because it can discriminate between the possible types of some answers. For example, within square root, if it is positive, that is b square minus 4ac is positive, then we get two real solutions. When it is 0, then what is happening? You get only one solution, so that is nothing but minus b divided by 2a only. So both the roots are coincident. When it is negative, then square root of negative, you get a complex number. So naturally you get complex roots for the equation ax square plus bx plus c. Now let us see another example of quadratic equation. Here the equation is 5x square plus 3x plus 3 is equal to 0. Now here this x square has got the coefficient 5 and x has got the coefficient 3 and the constant term 3. So 5x square plus 3x plus 3 is equal to 0. For various values of x, you get a graph as shown in this figure. So you get a parabola curve. It is a inverted parabola. It is looking like for this equation. So it is a graphical representation of the quadratic equation. It looks nice. So we can sum up the quadratic equation and the properties as follows. The quadratic equation in standard form, it is represented as ax square plus bx plus c is equal to 0. The quadratic equation can be factored. So a, that is nothing but x minus a1 into x minus a2 is equal to 0, where a1 and a2 are the roots of these equations. The quadratic formula will be x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. Here the b square minus 4ac is the discriminant of the quadratic equation. Why? Because if b square minus 4ac is positive, then there will be two real solutions. If b square minus 4ac is equal to 0, then there will be only one real solution. If b square minus 4ac is negative, then you get two complex solutions. Both the complex roots will be conjugates.